Hello everyone. This is the video for 10th class students, subject mathematics. The topic is real numbers. So, what are real numbers? As all we know, the real numbers are nothing but the set of all rational and irrational numbers. The set of all rational and irrational numbers will comes under a set of real numbers. Here we can see one figure. In this figure here we can see the natural numbers, the set of natural numbers, and the set of whole numbers which includes natural numbers, and the set of integers which are going to include whole numbers and natural numbers, and finally a set of rational numbers which includes integers, whole numbers, and also natural numbers. And here we can find one more separate set that is called irrational numbers. Okay, so the set of all rational and irrational numbers is called set of real numbers. So let me define the irrational numbers. See, as you know, there are three definitions for irrational numbers. We were discussed in our class also. So irrational numbers are nothing but the numbers which we cannot express in the form of p by q. That is the first definition. And the second definition is the decimals which never repeat and never end. This type of which type of decimals are going to never repeat and never end. Those decimals comes under irrational numbers. And also the pi. The value of pi is we can't define that exactly 3.14 like that and so on. It is going to continue. So these numbers, for example, the decimals which are not repeating and not ending. And also square root of 2. This is also one irrational number. Square root of some not a perfect square number is there. Then we can say that that is also irrational number. For example, square root of 3, square root of 8, that all comes under irrational numbers only. Now let us see fundamental theorem of arithmetic. As we discussed in the class, the fundamental theorem of arithmetic is nothing but any composite number can be written as a unique product of prime numbers. Okay, even you can follow this definition also. So any integer which is greater than 1, either prime number itself or can be written as unique product of prime factors. Anyone you can follow. And the statement and the proof of this fundamental theorem of arithmetic is there in Euclid's Elements. He written some 13 books on geometry. Those are called Elements. In that Euclid's Elements, you can see the statement and proof for the fundamental theorem of arithmetic. And Euclid was a Greek mathematician and often referred to as well-known name, that is father of geometry, Euclid. Okay. So here you can see the numbers. One is neither prime nor composite. So come from second, 2, that is 2. 2 is prime number, 3 is prime number, and 4 we can written as product of prime factors. 5 already prime number, so no need to write. 6 it is composite number, 2 into 3. So like this, any composite number, you see any composite number over here, we can write as product of prime factors. Here you see the prime factorization of the numbers and also how to find the HCF and LCM for these two numbers. So you know how to do the prime factorization for 72. After I am trying to find the HCF and LCM for these two numbers, so that I need the prime factorization of the both the numbers. So for 72, this is the prime factorization, 2 power 3 into 3 power 2. For 120, the prime factorization is 2 power 3 into 3 into 5. Now by the definition of HCF is nothing but it is the product of smallest powers of each common factor of the numbers. So first of all, you just list out the common factors. What are the common factors in both the numbers? That is 2 and 3. 2 and 3 is common in both the numbers. After writing 2 and 3, write their smallest powers. What is the smallest power of 2 over here? Smallest power of 2 is nothing but 3. What is the smallest power of 3 over here in these both numbers? That is 1. So 2 power 3 into 3 power 1, which gives 24. So that is the HCF. And coming to LCM. So by the definition we can say that LCM is nothing but it is the product of greatest power of each prime factor involved in the numbers. See, in these two numbers, how many prime factors are involved? 2, 3 and 5. Don't consider these powers, only the basis. 2, 3, 5. These all numbers are included in the prime factorization of the numbers. So what are their greatest powers? What is the greatest power of 2 over in these both numbers? The greatest power is 3. And what is the greatest power of 3? It is 2. And we have 5. What is the greatest power of 5? That is 1. Nothing more, we don't have nothing more than that. So 2 power 3 into 3 power 2 into 5, which is equal to 360. This is the LCM and that is the HCF. Now here, this is one important question. Generally they used to ask this question for 4 marks. So already we were discussed in the class also. So how to prove root 7 as a rational number? So let us take root 7 as some rational number. Okay, by contradiction method we can do this. So root 7, which is equal to p by q, where p and q are integers and q is not equal to 0. Now we are taking p and q are co-prime numbers. Also we should take as co-prime numbers which are not having any common factor other than 1. So like that we are supposed to take. After that, root 7 is equal to a by b. Let root 7 is equal to a by b. Okay, when b shift to this side, then this will become like this. Then square on both sides. If you square on both sides, that will become 7b square is equal to a square. So the meaning of this is nothing but whenever you shift 7 to this side, then that will become b square is equal to a square by 7. So what is the meaning of that? We know that a square is divisible by 7 after observing that statement, and a is divisible by 7. So we can write a is some multiple of 7. So a is equal to 7c, where c is an integer. So we can write this now as root 7b is equal to a. Instead of a, can we write 7c? Root 7b is equal to 7c. Square on both sides. So if you square on both sides, this you are going to get. And then b square is equal to 7c square. Then one more statement should be here, that is c square is equal to b square by 7. What is the meaning of that? Here b square divisible by 7. So b is also divisible by 7. So once you observe these two, here we got a is divisible by 7. Here we are getting that b is divisible by 7. Hence we can say that a and b having a common factor, that is 7 other than 1. So which is going to contradict our first one. First statement, that is nothing but we are taking a and b as co-prime numbers. So which contradicts with that one. So we can say that our assumption is wrong. So that root 7 is an irrational number. So similarly we can prove root 3 and root 5 also. For that also same we are supposed to take. If you want to prove root 3 as irrational, you just take root 3 is equal to p by q, and q is not equal to 0, p and q are co-prime, and do square on both sides and continue the same procedure. You can do that. And here we can see the one theorem. So for example, if x is any rational number whose decimal expansion is going to terminate, so then compulsory x can be written in the form of p by q, and also p comma q are going to be co-prime. And also one more thing about q, that prime factorization is of q is in the form of 2 power n into 5 power n. Okay, here you can see one terminating decimal. Here the decimal expansion is going to terminate. So in what way we can write? We can write that as 375 by 1000. Even 1000 we can write as, if you simplify this, you are going to get 3 by 2 cube. So after getting this, see, simplify this, you'll get 3 by 2 cube. After that, here you see 2 cube. 2 cube we can write in the form of 2 power 3 into 5 power 0. Because of 5 power 0 means 1 only. So as the denominator is in the form of 2 power n into 5 power m, we can say that is a terminating decimal. Or else if it is a terminating decimal, then its denominator prime factorization will be in the form of 2 power n into 5 power m. Let us see some more problems based on the same concept. Here also you can see it is a terminating decimal clearly because of the prime factorization of the denominator is in the form of 2 power m into 5 power n. So it is a terminating decimal. Even you can write the terminating expansion also over here. Just for that, what we are supposed to do is multiply both numerator and denominator with 5, so that you will get like this. So calculate this, the answer will be 0.115. The same thing here also. See, here I have 24 by 5 cube. Compulsory it will be a terminating decimal because of it is also in the form of 2 power m into 5 power n. So if you want to find the decimal expansion, multiply both numerator and denominator with 8, that is with the 2 cube. Already I have 5 cube, I am multiplying with the 2 cube, both numerator and denominator. Then this is the result you are going to get. So that is equal to 0.192. This is the decimal expansion. Okay, maximum we have this model sums only throughout the first chapter. So I hope I have covered all the concepts which are there in the first chapter, real numbers. So still if you have any queries, please share with me so that I can clarify your doubts. Thank you all of you.